Hello everyone, welcome back to the channel. In this particular video, I'll be talking about Uniswap V4. So in case you missed it, a few days ago Uniswap launched their V4, and this was something that was talked about since mid of last year. So really excited to see V4 being live. And in this video, I'm just going to talk about, I guess, a brief overview of what V4 is, and then maybe give you some introduction of where you can look through the different types of data that V4 has. And yeah, we'll just talk through it. So I guess the perfect way to start is, of course, by reading the the white paper. It's not much. It's quite short. But essentially, what V4 is that V4 is just Uniswap V3 with something called hooks. And hooks are, you can think of hooks as like extra instructions on top of the the traditional V3 pools. And I guess the other distinction also being that it is now a singleton contract. So I'll explain what all this means. So first up, I think it's easiest to show via, I guess first is the Uniswap, the UI, right? If you look at Uniswap UI Explore pools, you will see all this, Uniswap V3, right? All these V3 pools, and then if you click on the pool, you can see the pool address over here, right? So if I copy this and go over to Etherscan, this is a pool that holds all of the holds the two tokens related to the pool. In this case, is USDC and WEF. So and then another pool that let's say Red BTC and ETH has another token address, right? Has another address, and this address is different from the address that we just saw. So that's one of the key things about Uniswap V3, right? There's a factory address that you interact with, and that factory address creates all these different pools, right? In Uniswap V4, there are no factory addresses. Instead, it's all just, sorry, I should say there are no pool addresses. Instead, all of the pools are virtual, and they're all in just one contract. So that one contract is this. Is this address with a bunch of zeros and 4? This is the Uniswap V4 contract called the pool manager, and it has all of the liquidity basically, right? It has, yeah, basically any liquidity, any new pools that you create go through this contract, and the liquidity all goes to this contract as well. Another cool thing about V4 is that it now facilitates native ETH. So previously in V3 and in the other versions as well, you have to use WEF, right? Not native ETH. With V4 you can have. That's nice. And then of course, the main thing that everyone is talking about with V4, but not really widely, understood, is something called hooks. And I think the diagram that they have over here is kind of useful. So this is a simple swap operation, right? You start swapping here, and then this is your final, you finish the swap. And in between all these steps, you can sort of add in additional steps. So for example, before the swap actually happened, maybe you can tell the pool to do some stuff first, right? And then, after the swap happened, you can tell the pool to do some stuff first before the swap, fully ends. And so in their documentation, they actually talk about like what are all the different things you can do with hooks. I don't have it right here, but they talked about you can sort of have dynamic fees. That's one thing. You can have more efficient use of your capital. Like for example, if you provide liquidity and the liquidity right now is not in the active range, right? You can create a hook such that you can place your liquidity in a AMM. Oh, sorry, not AMM, like a lending contract, like RV for example, to earn interest, right? While your pool range is not in the active position, right? You know how V3 has all the concentrated liquidity, whatnot. So if it's not active, it can still earn interest. I guess that's the point of the hook. But there's a lot more stuff that is being enabled with this hook thing. And I'll also show you in a bit an actual implementation of a hook. But essentially, that's the general instruction for V4, right? It is a singleton contract, meaning it's just one contract. There are no additional pool addresses. And you can now have native ETH pools. You can trade native ETH, essentially. All right, so that's that. Yeah, let's dive into the data part. So if you go to the contract tab on Etherscan for this pool, also I'll leave all these links in the description as well. You can follow along. But if you look at the contract and then if you click on read contract, you would see a bunch of stuff. Right, just reading stuff. But if you click on the right contract, there's more stuff that you can find out. So here is where you can find all the different things that people can do with Uniswap V4. For example, one would be initialize. So in Uniswap V3, this would be a pool. This would be a factory address, and then you would initialize your pools. In V4, you'll be here, right? And then mint, I'm assuming you create a position, a liquidity position, and then if you want to change your range and whatnot, it will be modified liquidity, right? So on and so forth. There's also swap. So the things that you're used to. Now I'm going to show you one example of a swap. I believe this is it. Yeah. So just a very quick high-level example, right? This address over here interacted with whatever this address is. This address then helps to route the swaps. In one of the swaps, they swap with a Uniswap V2 pool, right? And then in one of the swap, they did interact with a V4, with a virtual pool in V4. And yeah, this just means I give the V4 pool some USDC and I get back this token, right? Yeah, that's pretty much it. Yeah, and let's look at the swap events. So this is the swap event. We would know because this is the V4 pool, so the same address that you interact with is the same address that emits the event. And if you've taken a look at V3 before, this is all very similar to V3. It's exactly the same almost. The only thing that I think is different is this ID over here. And this ID actually corresponds to your pool address, right? Your virtual pool address is now this ID over here. And then, yeah, the rest of the things is the same, right? They tell the amount 1 and 0, but they don't tell you the currency. Or they don't tell you what's the actual token 0 and token 1. So you need to join with the another table that has all the pool creations events, right? So that's a swap. And yeah, you should be able to decode this using fact event logs, or if you have it decoded after this video is out, it'll be in the text. It'll be in the text swaps table as well. Okay, now I want to show you something I think is very useful and a bit underrated. which is how do you use all these things to look for transactions. So let's first start with swap, right? So what you're seeing here is actually the function signature, which is just the which is the kcat hash of the function name and all the parameter types, but concatenate, not concatenate, substring, I don't know what's the word, like cut to the first 4 bytes. So we can actually take this here, let's copy this, and try to look for swap related transactions. So I'm going to find where's my query. Let's use this query. So it will be using the traces table, because whatever you saw over there is a function related data. So we will look in our traces table. So ethereum.core.effect traces. And because this is something new, I'm just gonna filter for like 30, right? And then here's where your filter comes in. This is what I copied, right? This thing. So we want it will be left input 10, and the reason why it's 10 is because it's the first 4 bytes, and 4 bytes means 4 bytes would have 8 characters long. So add 1, 2, 3, 4, 5, 6, 7, 8. And because there is an OX in front, that's why 8 plus 2 is 10. So left input 10 just means the first 10 characters from input, which should be the function signature. Okay, and remember in traces we need 2 things. We need the function signature and also the to address. And the to address is of course our Uniswap V4 contract. And the reason for that is because when you wanna call the swap function, you need to call it to the Uniswap V4 contract. So that's essentially what this is about, right? This is saying I'm looking for all transactions where they made a swap function call to the Uniswap V4 contract. So this will give me all possible swap transactions. So I just run this query. Oops, I forgot from. Yeah, there you go. I have all of my transactions where all these are V4 swaps essentially. So let's copy one and see what that looks like. I'm going to Etherscan, copy, paste the transaction, and let's look for V4. There you go, right? There is one V4 right here. I think that's it. This is one. Yeah. Now, to actually decode this, I think it's easier to just use event logs, just cause all the things are straightforward. Okay, cool. Yeah, this event logs, it's all there. But I guess my point of showing here is because using this right tab, where's my scan? I'll just use okay. Yeah, going to the right contract tab on Etherscan shows you all the function signatures related to this contract, and so you can find you can go through everything basically and see what sort of data is emitted in events and traces, right, and sort of do your analysis based on that. Now I'm gonna go to initialize because that's where the pools are first initialized, and so I'm gonna say, where's my query, right? Instead of the function, instead of swap, I'm just gonna say I'm gonna get initialized. So and left input 10 is initialized, right? And then run the same query. And this will give me all of the initialized contracts. So let's take a look at what that looks like. Okay, cool. So we see here a few things is happening. One is that the pool is being initialized, right? There's an initialized event. And in the same initialized event, this person is also modifying the liquidity. And I guess also providing the liquidity. That's why they're able to get this NFT mint, which is a Uniswap V4 position. Okay, let's look at initialize, right? So initialize here would be, again, in V3, there's a factory pool and you make new pool addresses, but in V4, all these are virtual pools. And so there is no one contract address. Sorry, there are no pool addresses. Essentially, it's just one contract address. And I'll show you how to decode this essentially. I already have the query written in here. And let me just walk through one by one. So first, I'm looking at the event logs table. Same filters, right? Which is just a date filter. And here is where event logs differ from traces. In traces, we use the left input 10 and 2 address. Event logs, we just need the contract address and also the topic 0. The contract address would be the Uniswap V4, so Uni V4. And this topic is the initialize. Okay, so yeah, topic 0 and contract address, combination of these two is the identifier that you can use in your event logs table. And now I have this usual substring just to break up the data column into chunks of 64 characters or 32 bytes so that we can then properly decode this. And I'll show you what it looks like. Actually, I have it here. So topics, right? All the topics. This is topic 0, and then this is the data in its casting form. And then here is the form where it's all in arrays. Okay, so here's how to read this, right? First, we look at the first thing, which is index topic 1. Now, index topic 1 is bytes 32, which means we would just use everything in the ID field as is. No need to substring, no need to convert, whatever, because 32 means 64 characters long. And then this is the ID. So this is the pool ID that we would use to join in with swaps. And then index topic 2 is just over here, right? Index topic 2. Because it's an address, so we apply the usual address treatment, which is if it's in topics, we would substring starting from the 27 character and then add a 0x in front to make this into a currency address, right? So here you can see now it's nicely written as a currency 0, and then do the same thing for currency 1, which is index topics, topic 3. And you'll notice that currency 0, sometimes there will be a bunch of zeros. Now this means ETH, right? Given that native ETH is now possible on V4, you would see currency 0 here being native ETH. Okay, now the next I don't know what this like parameter has no index in front, right? This is just phi, which means this is the first parameter in the data field. So in the data field, it looks like this, right? But if you decode it properly, we would have all this. So the first thing in the data field is phi. And so if you look at my query over here, segment first element, which is here, right? segment first element of data is the fee. And so because it's a fee and the fee is an unsigned integer, we just have to treat it as a, convert from hex to int. Next one being tick spacing. Tick spacing is an integer. So it's a signed integer, which means we need to apply the S2C filter here, not filter, S2C thing here, which means it can be a negative or a positive. And then it's follow the same thing, right? For address, we apply the address treatment, which is OX and then substring, the usual stuff. Again, unsigned integer, which just means convert to int, and then integer means convert to int, and then use the S2C. Pass the S2C. Okay, so I think that's it, right? If we follow all this regular treatment, and we will be able to get currency, that's a fee spacing, square root, price, and the tick. Now, I think probably the next or the important thing in initialize is that we get to see what is the hook address. Now, every virtual pool only is allowed one hook address, and the reason is that with just one hook address, you can actually apply a lot of different instructions with just one hook address, right? Like one hook address doesn't mean you can only apply the hook one time, right? Instead, the hook address itself allows you to have multiple hooks in it. So I have here an example of a hook. Let's see, where is it? Okay, here. So this might be a bit confusing. So let me just try to minimize some things. Okay. I think I have to. Okay. So what's important here is that you look at this pool manager, which is the Uniswap V4 pool, right? It's called. The swap function is called to the Uniswap V4, and remember that diagram earlier where we saw whenever a hook is called, for example here, right, start swap, you can have a hook that says, check the before swap flag. It's true, run the before swap hook, right? Which means if the hook address contains some instructions to do something before the swap, do that thing, right? And that's exactly what we're seeing here. We're seeing that, if I click expand here, the hook itself is called bunny hook, right? It's made by this team called Bunny XYZ. And so this bunny hook has, this hook address, it has some instructions to do some stuff before the swap is executed. And so that's why you can see it calling the before swap function. And then it does a bunch of stuff, right? I don't know what all this stuff means. It could be anything. It could be depositing to Aave. It could be checking for the price after the swap, or like do some sort of buybacks, right? All sorts of things is possible. But the main thing here is that it performs this before swap thing because it's the instruction in the hook address. And after all the logic is done, the pool manager then sort of ends the swap, right? This means the swap event has been emitted, which means the swap has been performed. And yeah, that's essentially how hooks work, right? You can sort of insert custom instructions at any point in the life cycle of a swap. In fact, there's even hooks for before and after initializing. Okay, so that's roughly the what hooks look like. And from the initialize event, we get the hook address, right? Now this is important because the next part I'll tell you how the hook address, like how from the hook address you can tell what exactly the hooks are. To understand that, if you read through the documentation, it tells you that it gives you an example of a hook address, and then it takes the C0, right, which is just the first byte, but actually it should take the 2 bytes, which means the last 4 characters, because 4 2 bytes represent 2 bytes represent 16 bits, right? 2 bytes represent 16 bits. And the number of hooks that Uni V4 has right now is 14. So it has to take the last 2 bytes. I think it's better for me to do an example. So let's do an example, right? Let's see. Okay, let's take this. Let's take the bunny address. What was the bunny? The bunny hook is this one over here. 10D05 is 10D0D5, and I see it in our query, which is this one, 10D0D5, which also makes realize something. 00. Okay, this is right. Yeah, so this is the bunny hook, and I'm saying we should take the last 2 bytes, which means the last 4 characters, which is just 188, right? So copy this 188, go to this website where you can convert text to binary. Right, I've already converted, right? It gives you this 13-digit binary. And the way to read this binary is that you can sort of think of it as like true or false statements to the hooks. So let me just copy this to here, right? I don't know if it's easier to see. And because it's 14 hooks, we can just add a 0 up front here. Since this is only 13 digits, so add a hook add a hook at the end. And then let's see, where is the hook? Okay, here are all the hooks. Before initialize, after, before. So I'm gonna copy this. Okay, this works, whatever. Okay, whatever. So this represents the first hook, represents the second hook, then so on and so forth, right? So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 14 hooks in total, right? And there are also 14 digits here. Now the thing about binary is you read from right to left. So the first character here, the first digit here is 1. So the first digit will tell you whether, all digits tell you whether it's either 0 or 1, right? So all 0 or 1 tells you is whether or not the particular flag is activated. So if it's 0, that means no. If it's 1, that means yes. So for example, before initialize means that means you're asking the question, in this hook address, are there custom instructions for before the pool is initialized? If it's no, you would have a 0. If it's yes, you would have a 1. So before initialize, 0 means there are no custom instructions for before initialize. What about the next one, after initialize? next one is 2. So 1, 2. It's again 0, which means there are no hooks for after initialize. Now on the fourth digit, there is a 1, which means something is true, and that something is this one after add liquidity, right? Because this is 3 and this is right. So there are custom instructions for after liquidity is added, right? I don't know what is that exact instruction, but I know that there is an instruction exists just based off of the hook address, right? Remember, this hook address that we obtained here is derived from this address. Take the last 2 bytes, which is 188, and then 188 change to binary, and then add I don't know this is leading zeros, right? Such that it's up to 14, right? Up till 14. Why 14? Because there are 14 hooks. Let's move on, right? So this is 1, 2, 3, 4, 5, 6, 7, 8. So what is the 8th? What is the 8th digit that has 1? Which means what is the 8th digit that represents something is flagged as on? And the 8th one is, did I count correctly? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, the 8th one is after swap. So something happens after swap. Hang on, did I do this? Did I do this something? Am I wrong? Oh, okay, I have all this upside down. This is the 13th. Okay, okay. So my bad. This is not 1, this is 14. It starts from upside down as well. So let me just label all this correctly. And this is 9. Okay, cool. Okay, so I guess same concept, right? 1 here being after remove liquidity return delta. So 1 is the first one. 0, which means no such instruction. And then the fourth one would be before swap return delta. So there's something before swap return something. Okay. And then the 8th one would be before swap, right? So that's why I was curious why before swap wasn't a flag when I was doing this earlier. So I guess this is why, right? This is in sort of backwards. And so you see that before swap flag is activated, and that is why if you look at the transaction again, there is the before swap hook being called, essentially, or function being called. What else, right? 1, 2, 3, 4. Number 12 and 13 is on as well. So 12 is before add liquidity, and 13 is after initialize. So after these two events, or before these two events are called, there are some hook instructions. Yeah, I think that's it. I just want to give a quick, or not quick, rather, I guess this video is quite long. I want to give an overview of what the Uniswap V4 looks like with regards to all these hook addresses, right? How do you get all the hooks? How do you convert the hook address to be able to figure out what hooks are being implemented? So that's how, right? This is exactly how. I'll probably make more videos on Uniswap V4, but I think I shall stop here. If you have any questions about Uniswap V4, please do leave them in the comments below. I'm still exploring the data, right? There there are a lot of things that I don't know yet. But yeah, hope to continue this journey. If you've watched all the way here, thank you so much for watching, and I'll see you next time. Bye.